All right, let's dive in. Today we're talking about one of the most fundamental pieces of AWS security, the security group. I want you to think of them as the ultimate VIP bouncers for everything you run in the cloud. They're the ones deciding exactly who gets on the list and who's left out in the cold.
And I'm not kidding, this is a super important question. A single, tiny misconfiguration in one security group can literally be the difference between a secure app and a massive data breach. So let's make sure you know exactly how to bolt that door shut.
Okay, so what is a security group really? At its heart, it's a virtual firewall. It's that bouncer standing at the door of your server or your database, meticulously checking the guest list. And it's not just checking who's coming in, the inbound traffic. It's also controlling what's allowed to leave, the outbound traffic.
Now, this is a super crucial point, so listen up. A security group isn't guarding the entire neighborhood. That's a job for a different tool. Nope, it's guarding one specific house. Or, in AWS terms, a specific virtual server, or even more accurately, its network interface. This incredible precision is exactly what makes it so powerful.
Okay, so to really master security groups, you got to get inside their head, You have to understand how they think. They run on just a few simple but really powerful principles. Let's break down their rules of engagement.
All right, if you remember one thing from this whole explainer, make it this. Security groups are optimists. They only think in terms of permission. They only have allow rules. There's literally no deny button you can click. So if you want to block something, what do? You just don't allow it. By default, everything coming in is denied. And interestingly, everything going out is allowed. We'll see why that matters in just a sec.
Let's go back to our bouncer. The bouncer doesn't have a list of troublemakers to keep out. All they have is the official guest list. If your name isn't on that list, you are not getting past that velvet rope. It is as simple as that.
Okay, let's talk about one of their superpowers. They are stateful. What does that mean? It means they have a memory. They remember the conversation. Once they let traffic out, they automatically remember to let the reply come back in. This is a huge deal, and it's totally different from another tool called a network ACL. A network ACL is stateless. Think of that as a bouncer with short-term memory loss. He's got to check your ID every single time you go in or out.
So let's paint a picture of how this works in practice. Your server sends a request out to, say, google.com. The security group, being stateful, makes a little mental note, hey, that request just left. When Google's server sends the response back, the security group sees it coming and says, I remember you, come on in. It lets the traffic through automatically. You don't need a separate inbound rule for it. It's just magic and super efficient.
All right, that's enough of the theory. Let's get our hands dirty and see how all of these rules come together to build a proper, secure fortress in a classic real-world application.
So first up, we have our web server. This is the front door, the public face of our whole application. Its security group needs to let people in, right? So we open up port 80 for regular web traffic and port 443 for secure web traffic. And we say anyone on the internet can come knocking. This is our welcome mat.
Okay, moving one layer deeper, we've got the application tier. This is the brains of the operation, and no way do we want the public just waltzing in here. So its security group has a really cool rule. We say, you're only allowed to accept traffic if it comes from our web server security group. We're not using IP addresses, we're literally telling one bouncer to only trust people sent by the other bouncer.
And finally, we get to the vault, the database. These are the crown jewels, right? So this security group is the toughest of them all. It allows traffic on the database port, say 3306 for MySQL, but only from one place, our application server security group. That's it. We've built a chain of trust, ensuring the only thing that can ever touch our data is our own application.
And listen, this brings us to a huge exam tip, and just like a fundamental rule for not getting hacked. Never, ever, ever open your database port to the whole internet. You just don't do it. You always use this security group referencing trick. It's the absolute cornerstone of building a secure cloud.
Okay, time to switch gears. Let's see if you've been paying attention. We're going to do a quick fire round, just like what you might see on an AWS exam. You ready?
Okay, question 1. It's a classic. You're trying to SSH into your instance, but nothing. Connection timed out. What's the very first thing you check?
Yep, 9 times out of 10, maybe even 99 out of 100, it's the security group. You got to check those inbound rules and make sure you've explicitly allowed traffic on port 22, the SSH port, specifically from your IP address.
Okay, next up, a bit of a trick question, so think carefully. You've identified a bad guy trying to attack your server from a specific IP. You need to block them now. So how do you use a security group to do it?
And the answer is, surprise, you don't. Remember what we said? Security groups are all about the guest list. They don't have a block list. To explicitly deny a specific IP address, you need to use the right tool for the job, and that's a network ACL or NACL.
All right, one more for you, and this one's a bit more modern, a serverless setup. You've got a Lambda function that needs to talk to your database, both running securely inside your private network. How do you make that connection happen?
Well, you use that exact same powerful technique we just talked about. You give the Lambda function its own security group, and then you go over to the database's security group and add a rule that says, hey, you are allowed to accept connections from the Lambda's security group. It's elegant, it's secure, and it scales beautifully.
And hey, just as a handy reference, here are some of the most common ports you're going to be dealing with. Knowing these by heart, like 22 for SSH or 443 for HTTPS, is just essential. Seriously, go ahead and pause here, grab a screenshot. This is one of those little charts you'll be glad you have later.
Whew! We have covered a ton of ground. So let's boil it all down into one final checklist, your must-remember takeaways from all of this.
Okay, here's your cheat sheet. Let's run through it. Security groups work at the instance level. They are stateful, meaning they remember connections. They only have allow rules. By default, they deny all inbound traffic and allow all outbound traffic. So, for controlling access to an instance, you use a security group. For explicitly blocking a bad IP, you use a NACL. Got it?
And that just about wraps it up. So I'll leave you with a challenge. Now that you know how all this works, what's the very first security group you're going to go check in your own AWS account? Go on, the best way to learn this stuff is to get your hands dirty. Thanks for watching, and go get those doors locked down.